Okay, today, lesson 6. What are we working on today? What are we working on? Rational numbers on the number line. Well, before we can talk about rational numbers on the number line, perhaps we should talk about what rational numbers are. Now, sometimes, I don't know if it's because I'm a woman, or because I'm Italian, or because I'm totally stressed out, I can get a little irrational sometimes and just completely fly off the handle and go on and on and on and just start screaming and yelling and losing my mind, and then I never stop and I'm yelling at my kids. They gotta clean their room and you left your food here and you gotta clean up and you never go to bed and you didn't do your homework and then you just on and on and on. I just get very irrational sometimes. Get a little irrational, and when I get irrational, I just go on and on forever. And then my kids are like, whoa, Mom's in a bad mood. But other times, I like to think that I can be very calm and a rational person where we could have a conversation and come to a solution. Come to a neat, clean answer. Okay? And the same is true with numbers. A rational number is a number that can be written as a fraction. However, the denominator cannot be 0. Okay? So integers, whole numbers, some decimals, those are all rational numbers. So give me an integer. Give me an integer. 6. How can I write 6 as a fraction? 6 over 1. So 6 is a rational number because it's neat, it ends, it can be written as a fraction, done. Now here it says some decimal. Yes?
Can it work with negative?
Absolutely. Negative numbers are rational as well. Good question. So if we had 1/2, that's also a rational number. Now some decimals we said. Decimals are rational when it terminates, meaning the decimal ends. So what is 1/2 as a decimal?
0.5.
Right, 0.5. So that's a rational number. And what about 1/3? What's that as a decimal? Well, no, 0.33333. It goes on forever. So it's 0.3 repeating. Because it repeats or has a pattern, that is also a rational number. 1/3 is also a rational number. Oh my gosh. What did you just say? Pi? You want to know if pi is a rational number? Ready? The count of 3. Blow at the board. 1, 2, 3. What about a number like pi? Oh my gosh. It's like you knew it was there. That's so cool. Okay. What about pi? Does pi end? No. Does pi ever develop a pattern? No. So pi is not rational. Pi is irrational because it doesn't stop. It goes on and on and on forever. It just keeps going and going and going. It can be very irrational. Okay? So pi is an irrational number. And very often irrational numbers are written with some sort of symbol, which you'll get into more, like you'll see square root. So here's 2 little jokes. We've got a couple chickens in a restaurant having some root beer, and see how this chicken over here on the right, his wobble thing, looks like pi? So the one chicken says to the other chicken, whatever you do not talk to that guy. He'll go on forever.
I watch you.
So now here we've got pi and his wife, 4. Now 4 is a rational number. They say opposites attract because apparently the rational number married an irrational number. And now they're in marriage counseling. They're being divided. They're dividing. And she's, number 4, is complaining, he's irrational. And he goes on and on and on and on and on.
Wife of pi.
So she's the wife of pi and they're looking to divide. Get divorced. Divide. Okay, so now that we reviewed rational and irrational numbers, let's take a look at these rational numbers on the board. And right now, on your own, on page 18, please complete 1 and 2. Convert the fractions into decimals and convert your decimals into fractions. So let's take a look. What is 1/2 as a decimal? Everybody? 0.5 or 0 and 5/10. 4/5. There are 2 ways to convert that to a decimal. Let's review. The first way that we could convert that is set it equal to a denominator of 10. So 5 times 2 is 10. So 4 times 2 is 8. So it's 8/10. Or you could have divided the numerator by the denominator, and that would have worked too.
Instead of 0.8, I just wrote 0.80.
Okay, 8/10 and 800 are the same thing. We want to keep it in simplest terms, though, because technically that would have been like 40 over 50, 800. It's really, they all mean the same thing. They all have the same value. And C, raise your hand, please.
I got 6.7.
Yep, 6 and 7/10. Very good. A, number 2. But we want to reduce that. Fractions should always be written in simplest form. So who reduced that? And B?
3 3/4.
Okay, well, first 3 and 75/100, which reduces to 3 and 3/4. And C? Some more people raising your hands.
36.9.
I want it as a fraction.
30.
How would I write that as a fraction?
Big,
How?
like 90 over 100 with the big 36, then like 9 and 10.
36 and 9/10. Okay, any questions on these? These are all rational numbers. Now, if we wanted to take a rational number and plot it on the number line, let's think about how we would do that. Typically, when we make a number line, each tick or hash mark, whatever we want to call it, represents 1. Don't write anything yet, put your pencils down. If this was 0 and that was 1, and I have to grab 3/10, I'm not cramming it in there. Oh, well, it looks like it's about, no, well, it looks like, no. We're going to number this number line. So that way we could plot the fraction. 3/10 falls between what whole numbers? 3/10 is between what whole numbers?
0 and 1.
Right, between 0 and 1. If I ate 3/10 of a pizza, I ate more than none, and I ate less than the whole pie. So I know that my number line is going to go from 0 to 1 and -1. And 3/10 falls in between 0 and 1. How should I separate? What units should I use when I'm labeling my number line? What units should I use? 1? Well, no, each tab. Because if I...
Each tab should be 1/10.
1/10? Why do we want to use 1/10? Why am I going to break this up into 10 pieces? Right, this is actually thinking back to our tape diagrams, how we were going to separate our tape diagrams. So because our fraction was in tenths, we're going to label our number line in tenths. So now you can go ahead and label your number line. 1/10, 2/10, 3. Okay? And now we have to number the other side of the number line. Because it wants us to plot the opposite as well. So if you look at the denominator, that will help you decide what units you should use to break your number line into. So this is negative 1/10, negative 2, negative 3, negative 4, negative 5/10, negative 6/10, negative 7/10, negative 8/10, negative 9/10, and that would be negative 10/10, which is the same thing as 1, negative 1. Okay? Now that I have my number line numbered, I can plot. 3/10 is right here. The opposite is over here at negative 3/10. Okie dokie? Grady, do you need one more second to catch up on the numbering? Or are you ready to move on? Because 1, if I did 9/10, then I would have 10/10. And what does 10/10 equal? 1 whole. Okay, let's look at the next example, or exercise. We're going to look at negative 7/4. Well, negative 7/4 are between what two consecutive integers? Now, consecutive means, here's that word consecutive. Consecutive means in a row. You have 2 consecutive days off, Saturday and Sunday. Okay? Those are consecutive days. So consecutive numbers would be 5 and 6, 7 and 8. Consecutive meaning in a row, together, one after the other. So now negative 7/4 would be between what numbers? Well, why don't we look at it this way? If we have negative 7/4, is that less than a whole or greater than a whole? Please put all of those down and participate in our conversation. That's greater than a whole. In fact, what is that equal to? It's equal to 1 whole and 3/4. So what two numbers would that be between?
1 and 2.
Right, well, since we have negatives, it would be between negative 1 and negative 2. So here we have our number line. I have to get down to negative 2. And over here to 2. What units should I use to number my number line? What units should I use? What? All right, where do you see a 5? What's the fraction that we're working with? Fourths. I want to find 7/4 on here. So what do you think I should number my number line with? Fourths. So let's do 1/4, 2/4, 3/4, God bless, 4/4, which is 1 whole, 5/4, 6/4, 7/4, 8/4, which is negative 2. So now I'll number my number line positives. Whoops. And then 8/4, which is equal to 2. So now that I have my number line numbered, negative 7/4 is here, and the opposite 7/4 is down here. All right, let's take a look at what we just did to answer these questions here. On the number line, each segment will have a length of what? What did we use? Each had a segment of how long? What were my units? Everybody? 1/4. In the fraction negative 7/4, the numerator is 7. The denominator is 4. And we said that the fraction is located between -1 and -2. Okay? So let's work on this last one quickly before the bell rings. Here's a real world example. Right now, this is how much water is in the lake. So if this is our starting point, we label that as our 0 on the number line because that's our starting point for how much water is in the lake. Well, it rained and it rose 1.25 feet. So what's a rational number to represent how much the water rose?
Would it be like 1.4?
No, 1.25. That's how much it went up. That's between what two numbers on the number line?
1 and 2.
Yep, very good. What length is each segment on here? Well, this went up by 1, 2, 3, 4 sections made it a whole. So if 4 sections made it a whole, that was broken into fourths, or 0.25. Because look, if we have to number this, 0.25, 0.5, 0.75, and then 1 whole. So where will the water level be after it rains? Graph it on your number line. It would be at 1.25. So after it rains, it would go up 1.25 to right there. Now, after all of this rain, it went down. Now it's at the opposite of where it was after the rain. So what's the opposite of where it was after the rain? Right, which would be right here. Okay? So these are all rational numbers, and this is how we can plot them on the number line by breaking our whole numbers, our integers, into smaller units. Okay? Oops. So graphing 4/3 on a number line is similar to graphing 4 because it's going to be 4 spaces away from 0. But it's just that our units are going to be different. Instead of our units being whole numbers, our units are now going to be fractions. So it's 4 spaces away, but it's not 4 spaces away. It's 4/3 away. You two are the last ones out because I didn't say to pack up.